It was pretty widespread. As Darren was showing us, as you see this map, did you feel it? Well, a lot of people felt as far north as Novato, all the way out to Stockton and Modesto. They felt it, and you definitely felt it if you were in the South Bay this morning.
Yeah, we talked to Mary Lee. She said that and she's down in San Jose, very close to the epicenter, and said she felt like her entire house was shaking. You can see the windows rattling there, and it is unnerving. Even though if you've been in many earthquakes before, when you feel that initial jolt, it's scary. I've been in many earthquakes, and it still kind of takes your breath away there for a minute. You're not quite sure, do I get under the desk? What do I do? You have to kind of remind yourself. You go into a little bit of a shock there, but good to know that it was a 5.1, no damage, no injuries, and but of course, folks down in San Jose, they really felt it. Up here in San Francisco, you felt it. Whether or not you felt it kind of depended on where you were.
So let's go to Kimberly Bisniak at San Jose Department of Geology. So Kimberly, can you hear us right now?
Yes, I can.
Yeah, thanks for joining us. So what can you tell us specifically about this earthquake?
So this earthquake, one of the reasons why we felt the earthquake so strongly, even though it was 5.1, is that it ruptured. It was a shallow earthquake in a sense that where the earthquake started, nucleated from, was only about 6.9 kilometers depth beneath the surface. And it occurred on a fault. It looks like to me, just based on looking at the map of the location of the epicenter, the Calaveras Fault, which is a right lateral strike slip fault that runs along the East Bay near, just south of San Jose.
So a relatively shallow earthquake, Kimberly. And can you describe a little bit what that means? That just means it doesn't go to the depths of the core. What does that mean when we say a shallow earthquake?
So a good way to think about an earthquake is, I use this analogy, is like when you throw a pebble into a pond, the pebble, when it hits that water, is the earthquake, okay? And then an earthquake is basically energy. And so when an earthquake ruptures, it basically releases energy. And that energy travels in the form of waves, similar to the ripples that you see when you throw that pebble into a pond. And so you can imagine if you had the earthquake and that energy is being released, and you kind of turn those ripples 90 degrees, right? That if you that energy, when it reaches the surface, those initial ripples, if you were very close to the surface, then you feel bigger, more ripples traveling through to the surface. Whereas if that earthquake were to occur much deeper, then you feel those ripples a little less.
Interesting.
And Kimberly, so much is made about the different fault lines from the San Andreas fault line. Lately, we talk so much about the Hayward fault. We have a map right now of the Calaveras fault. Can you talk about the significance of this fault line, where it runs, and some of the communities that potentially are impacted by this fault line?
Sure. So the Calaveras fault is runs along the East Bay, and what happens, the Calaveras and the Hayward fault are the two main faults that the USGS and forecast in the Earthquake Science Center is likely to rupture in a magnitude, 6.1 or above in the next 30 years. It has they both have very high probability to rupture in what we call a surface rupturing earthquake, whereas when we have an earthquake, what we felt were just kind of like the energy waves, and there wasn't any rupture on the surface. We anticipate that the earthquake will rupture. And what happens with the Calaveras and Hayward fault is that the Calaveras fault comes up and just near Mission Peak takes a left step. It steps over, and the Hayward fault picks up. And so these two faults work as a system similar to the San Andreas system that is a plate boundary between the North American plate and the Pacific plate. And what's happening is that these two plates are moving past each other. And as they're moving past each other, all of the faults that are riddled across the Bay Area, including the San Andreas, Hayward, Calaveras, where we are, accommodate that movement between the two plates.
Okay.
All right, thank you very much, Kimberly Blizniak with the San Jose State Geology Department. Bree, what you got?
Well, those of you on Twitter who are responding are now starting to show us some video. Watch this. This is a shelf here, we understand, in the city. Somebody had the presence of mind to turn on their phone. Let's listen. All right, no sound there. But you are seeing kind of some waving and some shaking there. So, you know, as always, let's continue this community conversation. This is the place where we will gather around the table, so to speak. There you go. You see a computer there shaking back and forth down in Santa Cruz. So somebody there saw that video, and we'd like to see more. Obviously, you see them head to the door before they cut the video off.
All right, yeah. The first video was from Liam Mecklem, who's a friend of KPIX 5, and he's in San Francisco. And you can imagine he was a little nervous there watching his shelves vibrate a little bit there. All right, let's get to Ryan Hayes. He is in the Silver Creek Valley Country Club. That's down in San Jose. Ryan, can you hear us?
Yes, I can hear you.
How does it feel where you were at?
It shook our clubhouse pretty good. It kind of startled all of us here in the golf shop, and we were surprised by it and thought it was just, you know, something moving around in our clubhouse, and then realized it was an earthquake.
I can imagine all those golf clubs rattling back and forth there. Anything fall off the shelves? Any minor damage there?
No major damage. Just some sunglasses in the shop fell, but other than that, it held up pretty good. But it shook us really hard, yeah.
I can imagine if were there folks out on the golf course when it happened. Were they wondering what was going on?
There were. We did get a few phone calls from people that were asking if we felt that and if that was a earthquake, and we said yes, it was. And but yes, everybody here is okay.
And have you ever been in an earthquake of this size before?
I have not. I've lived in the Bay Area since about 2004, and this was probably one of the bigger ones that I've ever felt.
So, Ryan, kind of describe how did it feel and how long did it go?
It felt like a big old rattle, and it probably felt like it went on for about 5 or 10 seconds, and we just kind of stood and weren't really sure what to do. And then once it stopped, we all felt better.
And I'm curious, you know, I can imagine what a golf shop is. There's lots of things hanging on the walls there. Anything you guys are kind of doing, make sure things are tightened up and secure? Anything that is different about your operation right now, just to kind of make sure everything is safe?
Yeah, we just walked around and looked and make sure everything was still in place and checked on everybody, and as a whole, it held up pretty good. So nothing too major.
All right.
Thank you very much, Ryan Hayes with the Silver Creek Valley Country Club in San Jose. Let's get back to Darren Peck, a little bit more on the epicenter where this quake was actually felt.
And to be specific on that, just about 2 miles south of Mount Hamilton. If anyone's ever taken the drive up that road, it's a gorgeous winding road that goes into the mountains to the east side of the Santa Clara Valley. Mount Hamilton's got that historic Lick Observatory on it. The epicenter for this was about 2 to 3 miles south of that in the hills. In fact, there's a county regional park there that's nothing but wide open space with no structures on it. That's where the epicenter of this earthquake was. So a little more perspective on where this was felt, because the information for how strongly this was felt and where it was felt is constantly updating. So we're going to start out with the close-up view to show you pretty light. In and around the South Bay, when you get into the shades of light green on this map, the only thing this map is telling you is the intensity of the shaking that's been reported by people. And that light green on there, that scale, is like a moderate, like a weak to moderate. That's great news. We're not seeing a whole lot of yellow or orange showing up here. But if we come out for the wider view, now that we've had some time for the reports to come in, this is new information to see how widely felt this is being reported. And it does extend well up into the North Bay now. Folks in Sonoma and Napa County are saying they felt it, although that shades into the light green. We know it was felt through the city and the East Bay. We've already had firsthand reports of that. But look how far south this went as well. A little bit farther south than north. And the epicenter coming in the South Bay, we haven't seen an earthquake this strong in quite a while in the Bay Area. The last one, which was notably stronger than this, was the earthquake that happened in Napa, which so many of us remember. That one was 2014. That one was a 6.0. And that one, we did have, images of damaged buildings. This one, that is not likely. A 5.1 kind of falls in that range where it's going to be felt. You might have some things that have fallen off shelves, but from a 5.1 to like a 5.5, you're not really going to get a whole lot of structural damage to buildings, especially one that is centered in the mountains like that and not directly underneath any communities or urban centers. Now, in terms of the fault line, we were getting information from the seismologist on the phone about 20 minutes ago, and we can visualize not only the Calaveras Fault, but how close it is to the Hayward. And if you watch the red lines, the Hayward Fault's the notorious one. The Calaveras Fault is the one over here that kind of cuts up through the East Bay Hills. That name doesn't roll off the tongue for most people. San Andreas does, Hayward does, and that's pretty much where it stops. But there's a whole series of fault lines here which splay off of the main San Andreas to kind of take up the movement. I mean, it's all doing the same thing. They're all strike-slip faults. But it doesn't just happen on the San Andreas. There's so much movement in the Earth's crust happening that you've got all of these different fractures trying to accomplish the same thing, which is taking the Pacific plate over here and moving it towards Alaska, and the North American plate over here and moving it down to the south. So this was one small little movement to accomplish that process. The Calaveras Fault is the southern edge of this complex that's kind of a juncture between the Hayward and the Calaveras. They do kind of verge. And there has been some recent work done from the USGS to look at those two with the potential to work in tandem. This likely wasn't that. This likely was centered strictly on the Calaveras Fault. And by the way, she did go into the depth on it, relatively low. I mean, she gave it to you in kilometers. This was about 4 miles deep. For perspective, Loma Prieta was about 13 miles deep.
Okay.
So that lends a little more there.